Yes, good evening, everyone. Good evening, guys. Hope my voice is audible. Is it audible? Can I get quick confirmation on chat box? Okay, thank you all, guys. Let me share my screen. So before that, let me ask you one question, guys. So how was the midterm examination? So how was your examinations, guys? Was it good, Jyoti, Tanya, Arup? Thank you. Good. Okay, guys, we have left with 4 more minutes. So please put a message on your WhatsApp group. So ask everyone to join immediately. So now we are into 10th session, right? But still have not covered 8th session concept only. So I have left with last tool, right? Sir, when we get assignments I will post you soon, guys. Maybe by this week or by before your 11th session, I'm going to share assignments. Jyoti, usually, yeah, I'm going to give you 15 days of time. No need to worry about that. Okay, I will give you 15 days of time. So it will be having two part. So part one, I'm going to give you data set. So on that, you have to use tools to execute it. And second one, this time I'm introducing situated learning. So situated learning is nothing but you take your problem, your company problem. See, for example, you people are working in a company. So in company, you define a problem statement and you use so any of the big data tools to solve that problem. So these are the two parts I'm introducing now. So for first part, I'm going to give you 10 marks. And for second part, I'm going to give you 10 marks. Okay, this is what I have planned. So yes, by this week, I will release the assignment, guys. So I think everyone done with your group, right? Still, we have a problem in group. Tanya, actually, yes, sir, both in groups. So which group I'm not understanding. Actually, I asked you people to make a maximum size of 4 members, but I have seen many members have done 5 members. So that is the problem. See, we are not allowed to 5 members in a group. So please see those who are having 5 members in a group. You see you discuss yourself, and one has to join in the other group. Otherwise, they have to create one more group. Okay, Tanya, you understood? Jyoti? Yes, group. I have seen many people have five members in a group. So clearly, we have told you, right? So you people have to create a maximum of 4 in a group. So please convey the same message to your friends, guys. So today I have only 15 students. So before your assignment, you have to complete with the group formation. Okay. So based on that only, I can release the assignment. Yes, guys. According to planning, maybe yes, by next week, I'm going to release the assignment too. So 11 session means 12, 13, 14. So you'll be having 3 weeks of time. So before that, you have to submit your assignment. Varun, then why you have joined in 5 members group? Hmm? So before that only you people have to see, right? Otherwise, learning facilitator is going to remove you people, and then he will create a separate group. Okay, guys. Yeah, it is a time to start our session. Let me start with the. So I'm sharing my screens, guys. So this is the screen. Yeah. So hope my screen is visible to everyone. Is it visible, guys? Can I get quick confirmation? So if it is visible, can you type visible and chat box? Can anyone? Not. No. Is it not visible? Okay. Once again, guys, and I have not shared my screen. Okay. Yeah. I forgot to share my screen, guys. Now is it visible? Yes. Okay. Thank you, guys. Okay, guys. Yeah. Without wasting time, let us start today's session. No, this is not. This is 8 session 1, right? Let me close this. Yeah. Guys, as I told the last class, we have left with one tool. That was your Hive. So in today's session, I'm starting with Hive. And after completion of Hive, we will jump to 9th session concept. So again, in 9th session concept, I'm teaching you 4 more tools. That I will give you introduction later. So let us start with Hive today, guys. Guys, you just look at here. So guys, actually, we all know, right? Hive is the SQL interface to big data. But what happens if your crucial data is still in a what legacy Oracle database or streaming live from millions of IoT sensors? Hive cannot help until the data is already inside HDFS. Okay. The challenge of big data is not just processing. So it's movement and also coordination. So this is also very, very important. You just imagine. So having 10 different processing steps that need to run in a sequence every night. Okay. So one mistake and the whole night is wasted. So today, guys, we are conquering Scoop, Flume, Zookeeper, and Woozy. But before that, let us start with the old concept. That old concept was Hive. Guys, you can see here in this slide what exactly I'm showing you here. So why Hive? So why Hive? That is the question, right? See, we use Hive because it provides a SQL-like query interface. Okay, that's why. So this Hive is also called as Hive Query Language. Hive Query. Are you all getting my point, guys? So it is a SQL-like query interface over large structured data in HDFS or Hadoop system. And it acts as a data warehouse on, see here, I have mentioned the second point. It acts as a data warehouse on HDFS or Hadoop. Understanding my point, guys? So crucially, remember, it is not an RDBMS with transactions. So it's meant for OLAP. It means for OLAP. That is online analytical processing type queries, not real-time row level updates. Understanding my point, guys? So this is why. So why we have started what using Hive concept. And you can observe in the second slide. So second slide is giving a complete architecture of Hive. Okay. So you look at the diagrammatic representation. So this diagram visualizes the separations of concerns. Okay. So you can see here. So we have metadata. So you know the purpose of using metadata, right? The metadata holds the schema metadata. Try to understand this. So this will host the schema in a stored relational database. So this will be containing structure of table, partitions, columns, data types, and deserializer to what read or write data. So all these things, guys. Okay, so this is the main purpose of using this component metadata. And after that, you can observe here. So we have a Hive query language process engine. Guys, the Hive query language process engine has the compiler that translates Hive query language into MapReduce jobs. Understanding my point, guys? So it will take the input. Okay, it will take the input and see, it will take the input from the metadata only. See, look at the arrow mark here. So it is taking data from the metadata and then it will see inside this we have a compiler. So this compiler translates Hive query into MapReduce jobs. Understanding my point, guys? See, after completion of this, so we have an execution engine. So once it is converting everything into MapReduce jobs. And also, this MapReduce format is going to start executing that MapReduce job. Okay. And one more very, very important thing what you have to observe here is, so this is, see, everything of your Hive components are sit on top of the HDFS or HBase data storage. Either you can store on top of HDFS or you can place on top of HBase also. Understanding my point, guys? So, and also you can look at here. So you have a what user interface. You know the purpose of user interface, right? See, user interface means here we have what 3 different types of interfaces. So by using web, you can interface with the Hive architecture, or by using Hive command line, you can communicate, or by using HD Insight. So my suggestion is, so always go with Hive command line interface to communicate with this architecture. So this is about Hive architecture and also components. And next slide, you can observe here. So now I'm talking more on Hive query execution flow. Guys, here you can observe. So how many steps we have here? So totally we have 10 steps, correct? No? So look at here. The first step is started with 1 and the last step is 10 here. So totally we have 10 step flow from query submission to result delivery. Understanding my point, guys? So let me explain you each and everything in detail. So now you will understand so how this query is going to execute. Okay, the very first thing is, so the very first step you can observe here. So here we have a step 1. The driver sends query to the compiler. Okay, look at here. So the point is mentioned here. Driver sends compiler to create a query plan. So indirectly what driver is doing? So driver is sending the query to the compiler. Understanding my point, guys? This is the very first step. And the next step, so where do we have 2 here? See, here we have a 2, right? See, it is sending, driver is sending to the compiler. The compiler consults the metadata. See, compiler will not simply sit. Correct? No, immediately, so it will consult the metadata to validate and get the schema information. Get the schema information. Okay, so once everything is done, so it builds a query plan. Okay, it builds a query plan. You're all understanding what exactly I'm trying to explaining you here. The compiler, see, after completion of this query plan, the compiler, see, again, it will come back to compiler. The compiler optimizes this plan. See, for example, by combining consecutive jobs. Okay, so once everything is done, so it will go back to driver again. So this driver will send the entire job to the execution engine. Then what is the responsibility of this execution engine? See here, this is directly attached to MapReduce, right? So the execution engine runs the plan via Hadoop MapReduce. See, look at here, the 7th step. So there is a communication between execution engine and also MapReduce. So what is the MapReduce job? You know already what is the job of MapReduce, right? So after completion of this MapReduce job, so result will come back to execution engine and again it will come back to the driver. Driver will send result back to the interface. Understanding my point, guys? So this is how the query is going to execute. So this is the flow of query execution. So hope till here everything is clear. Shall I get quick response and chat box? So till here everything is clear. Shall I get quick responses, guys? So hope you all understood, right? The flow of execution. Yes. Okay. Thank you all, guys. Now what you have to observe. So you have to observe the next slide. See, next slide. I'm trying to what? Focus on the two main table types. What are the two main table types here? Okay, look at here. See, this table concept is same as your RDBMS table. So it will be having rows and columns, everything, guys. It is very much similar to your RDBMS table. But data is stored in the HDFS directory. That you should understand. So as I told, so here we are focusing on the two main table types. The very first table type is called as managed tables and second one is called as external tables. Okay, then what is the very first one? Managed table. Guys, Hive manages both the data and the metadata. Understanding? So if you drop the table, the data in HDFS is also deleted. So that's why it is called as managed table. Understanding my point, guys? Then what about the second one, external tables? Guys, Hive only manages the metadata. Okay, the path is already recorded. Okay, if you drop the table, the data remains untouched in the HDFS. See here, your dropping table means it is deleting. But in case of external tables, not like that. Okay, if you drop the table, the data remains untouched in HDFS. That is in case of external tables. So this is a vital for data injection pipeline. Correct now? Data injection pipeline. I will talk more on this partition and bucket in the next coming slide. So now you all understood, right, what exactly the definition of managed tables and also the definition of external tables. So now we are moving on and we are talking more about partitions and also bucket concept. You all look at here, guys. So I'm continuing with the data model here. So tables are, guys, what exactly we are doing here? See, we are taking a table and these tables are structured further using these two concepts. So one is called as partition and second one is called as bucket. Understanding my point, guys? So then what is partitioning, guys? You just understand partitioning splits the data based on key. Okay, so we are splitting the data here. But what is the thing we are taking to split it? So we are taking key to split the data here. Let me take the examples, guys. See, student data. See, suppose you have a student data. So then how you are going to split it? So based on the department, you are splitting the data. Look at here. See, department EEE, department ECE. See, based on these two, we have partitioned data into two different tables. Understanding, guys? And this is implemented as separate subdirectories in HDFS. So this will consider a separate directory and this will consider a separate directory in the HDFS. So hope partition is crystal clear to everyone. Then what about bucketing? Guys, bucketing is an additional subdivision within the within the partition. Look at here. This is partition. Again, we are subdividing this into two different parts. So department triple E is divided into two buckets. So bucket 1 and also bucket 2. So even same with the ECA also. So department ECE is divided into two different parts, bucket 1 and also bucket 2. Understanding my point, guys? So it is a subdivision within the partition. So based on the hash of the column, which maps to the actual file. Which map to the actual file. So this is the concept of bucketing. And moving forward, see, I'm talking more about partitions here. So we are trying to what compare between data partitioning and also bucketing here. Guys, look at here. Say I'm starting with partitioning. Guys, this partitioning is very good for distributing execution load horizontally. Understanding my point, guys? And also it is good for faster queries on low volume data. Low volume data. See, for example, I mentioned an example here. Search populations from Vatican City returns faster than the China. Correct, no? So like searching a small city. See, Vatican City is a small city. But there is a disadvantage of this partitioning, guys. What is the disadvantage? So it can create too many small directories. Correct, no? So it will create what? Too many small directories. That is one disadvantage we have with respect to partitioning. Then what about this bucketing? So where it is good? Guys, bucketing is good when partition sizes vary a lot. Okay, so it ensures almost equal volume of data in each bucket. So which is crucial because it makes map side joins pre-sorting much quicker. So this is the comparison between data partitioning and also bucketing, guys. Now let us take one small example to explain on this. See, examples of partitions and also buckets we have taken here. You try to understand the code we have given here. See, we are creating a table. Create by using keyword create, we are going to create the table. And this is the table. This is the common phrase we are going to use here. And next we have bucketed user we have mentioned here. And inside that, so we have taken first name, data type, last name, data type. These are all data means what? Variables. And these are all data types. Okay, everything we have taken here. Let me explain one by one. Guys, this slide shows the specific create table syntax. Okay, it is demonstrating how to declare both partitioning and also bucketing. So this is again, guys, I'm putting 3 stars here. This is very, very important concept. Okay, so let me start with the very first one. Look at here. So what I have mentioned here, guys, partitioned by, look at here, everyone. So everyone look at here, partitioned by country varchar 64 we have mentioned here. See, this is creating a folders, correct? No, this statement is creating a folders. Okay, and next to that you have one more line here, that is clustered by. See, this clustered by, sorted by into 32 buckets. So this groups records by, this groups record by state into a controlled number of files. Understanding my point, guys? So hope this is clear to everyone. So if you have any query on this, please do ask me in the chat box, guys. What about for execution engine to Metastore like 7.1? Jyoti, I'm not getting your question. Can you elaborate the question? Jyoti? Okay, in Hive, I understood. But what is your question? So can you elaborate your question? You're asking about Hive architecture? Okay, there is a point 7.1. Yes. Yeah, in Hive architecture, you're talking about Hive architecture, right? See that seventh point I've explained you, right? Seventh point is nothing but 7.1 and also 7.2. Okay, so sir, in the query, the buckets are created on the basis of state, right? Yes, 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 correct. One second, guys. Okay, sorry for the inconvenience, guys. I got some disturbance. Okay, yes, sir. So many of them started asking questions, sir. So let me explain you one by one, guys. See here, yeah. So before that, let me explain you the architecture again. So here we have an architecture, right? I was talking, somebody was asking questions on this. So let me clarify on this. Guys, actually, you are all seeing the components here, right? So the very first component, what you have seen here. So you have seen interface. Okay. So user interfaces, you can call it. Okay. So here in diagrammatic representation. So here I have mentioned user interfaces. So user can interact with Hive through several interfaces. So one, he can use Hive command line, he can use web UI, and also he can use HD Insights. Correct? No? One second, guys. Sorry, guys. Okay. So as I told, so we are using three different interfaces here. And also after that, I've told you about metadata. Okay. This is the most unique and critical part of the Hive. Okay, that is called as a metadata here. The metadata, meta store, stores the metadata or schema for all the data sets, all the tables. That part also I already have told you. See, it stores the structure of table, partitions, columns, data type, everything. And it also records the where the actual data resides, the HDFS files or HBase metadata where data is stored. And the meta store itself is stored in a relational database. Okay. So why this is very, very important? So you can ask me a question. Because Hive is a schema on read system. Okay. The data in HDFS is just raw files. So it is in the form of what CSV or it is in the form of JSON. The meta store is what imposes a structure. So either it would be there in table format or it would be there in a schema format, column schema format on that raw data. But only when you query it, this structure is what makes Hive query language works. Okay, that you should understand. And next to that, we have a Hive query language processing engine. So here I've told you the third component, right? So it has a compiler. Inside this, we have a compiler. So that is the core of the Hive query language process engine. This compiler consults metadata from the meta store to understand the schema. And after that, translates a query into MapReduce jobs. See, this your understanding means next slide, it is very easy to understand. So that's why I'm repeating the concept. Okay, next, after that, we have an execution engine. The execution engine runs the generated MapReduce jobs on the Hadoop platform. So it is reading data in HDFS or in HBase system. So Hive is the complete package for bringing RDBMS style querying to the big data world. Okay, so here, yes, sir. So this image already I've explained you, right? So one more image, you are asking more question on this, is it? So here, so let me explain you once again. This is very, very important to understand. So the very first one I've told you, right? Query submission. So the Hive query is sent from the user interface to the driver. So I have written a what query here. This query is transformed from interface to driver in the very first step. And what is the step 2 here? Driver sends the query to the compiler to create a query plan. Correct? Now that already I've told you. And next to that, see, look at here. Here we have a concept. Let me write here. AST and semantic analysis. Or you can call it as a compiler also. Guys, the compiler first builds an abstract syntax tree. It will build abstract syntax tree. Try to understand this. It then perform semantic analysis. Okay. Semantic analysis of what, guys? Semantic analysis of query. So it is going to check columns or tables exist, our types are matching or not, everything it is going to do there. And after performing everything, so this is going to create a query plan graph. Query plan graph. See, I'm explaining you in detail, guys. So once you're not understanding, now you will understand. Then what we are doing in a fourth step. So here query plan graph is ready. Then what we are doing in a fourth step, to do a semantic analysis, the compiler visits the or consults the meta store. So it needs the schema information to correctly map the query to the underlying data files. The metadata then respond with the requested metadata. This is the fourth step. After fourth step, we will jump to fifth step. So here we are we are performing the optimization and also final plan. The compiler optimizes this DAG. Okay, so possible optimization includes combining consecutive jobs or splitting task. Okay, the meaning of this is it is going to insert combiners before reducer. Okay, then after that it will send to the next level. Optimized plan back to the driver. Look at here. Optimized plan is back to the driver now. See, once everything is present on driver, so we have to plan to execute the engine. That is going to happen in a sixth step. So the driver sends the plan to the execution engine. Look at here. Driver sends a plan to the execution engine. So many of my students, Jyoti was asking a question on 7.1, right? Guys, 7.1. So both are performing job execution. So both are performing job execution. The execution engine essentially execute the query plan via Hadoop MapReduce job in seventh step. So this involves, see, this involves this metadata also, because schema is very, very important, right? So that's why it is involving metadata in 7.1 step. And along with that, it involves reading data from the HDFS. Look at here. It will involve one more, that is HDFS or HBase. Okay. And finally, guys, so next, what is the next step? So we have eighth step, right? So where is the eighth step? This is the eighth step, and we have ninth step, and we have last 10th step. So once MapReduce jobs are completed, the final result is sent back through the execution engine to the driver, and driver to the Hive interfaces. Okay, this entire flow, especially the consultations with the meta store in 7.1 and the translation to MapReduce, is what defines the speed and capability of Hive. Because of the MapReduce step, the overall process is batch oriented and takes time, but it is guaranteed to be correct and can handle petabytes of data. So now I think I answered Jyoti's question. Jyoti, now everything is clear. Jyoti, you have understood? Have you understood? I think I have answered the query 7.1. Yes, Jyoti? Is this clear? And yes, I have few more questions on. One second, guys. Why it is not charging? Okay, I have few more questions on commands. Is it? What is this question? Let me check once. Okay, so many people are asking why it is 30. Okay, so let me explain you the command, guys. Let me explain you the concept again, then you will understand. Yes, you people were talking about this code, right? Yes. Yes, now look at here, guys. Let me explain you in detail what exactly we are doing here. Okay. So this is, see, we are dividing this into partitions and also bucketing concept. Once again, guys. So example, I will explain you now. Partitioning, bucketing, you all understood, right? Yeah. I was talking about this examples, right? Guys, you just examine the practical create table statements that utilizes both partitioning and also bucketing to structure data efficiently for querying. So this is how we define bucketed users. Okay, this bucketed users table. Okay, so we have written create table, bucketed users, and inside that we have written commands here. Okay, inside that we have written commands here. Correct? No? Yes or no? And also we have mentioned written comment here. A bucketed sorted user table. And after that, we are dividing it into partition by and also clustered by. And many of the people are asking about this 32 buckets. Now let me break down this into everything, guys. So very first thing I'm explaining you on this partitioned by. Guys, this is the highest level of physical organization. Try to understand this first. For every new country value, a new subdirectory will be created on the HDFS. Understanding my point, guys? See, here we have mentioned country. So for every country, so it is going to create a subdirectory. That is the main purpose of using partitioning. And then what is the goal? Guys, queries that filters by country will only read the small subset of data in that country directory. That is the main purpose or main goal of this. And next to that, guys, so we have clustered by. Okay, so within each country partition, the data is divided into buckets based on the hash of the state. So one student asked a question on this. So this is based on the hash of the state column. Okay, the main goal of this is, see, we are to group state records into the same bucket. This ensures that all records for the particular states are in the same small file. Correct? No? This is crucial for localizing joins and also aggregations by state. So if anybody is asking aggregate it by using statements, then we can use that. And next to that, guys, so we have one more line here. What is that? Sorted by city into 32 buckets. So we are defining a fixed number of buckets here. How many fixed number of buckets we have taken here? 32 buckets we have taken here. This is how we control the total number of buckets and thus the number of data files within a partitions. Okay, the records within each bucket are sorted by city again. So this greatly speed up range scans and merge operations within the bucket file. And finally, everything is done, right? Once everything is done, so we are going to execute stored as sequence file. So the data will be stored in this binary format. So which is often used to save space and can be processed efficiently by the Hadoop system. Guys, this structure allows Hive to perform an incredibly optimized query. See, for example, you're performing select star from bucket user. Where? Okay, this is the query you're writing. Country is equal to USA. You're writing country is equal to USA, and along with that, you're taking state equal to California. California ordered by city. So this query you are asking means, see, this query engine will jump directly to the which country, guys? It will jump directly to the USA. USA partition, right? Because we have a separate directory for USA country. So then in a single bucket that contains all California state records. Okay. So since the data is already sorted by city, the retrieval is near instantaneous. Understanding my point, guys? So hope now I answered questions for all the answer for all the questions. So is it clear to everyone? Is it clear to everyone? Shall I get quick response from Tanya? Shall I get quick response from who is this? Samanvita? Shall I get quick response from Samanvita again? Samanvita asked 2 questions. Am I cleared all the doubts? So now you people are clear with all the queries, right? Okay, fine. See, I have not explained in detail, guys. Once I'm explaining you in detail, then you will understand. There is no issue with that. But yes, okay, no problem. Okay, let me move forward, guys. Now look at here, everyone. A point about map side joins and buckets. So detailed classroom style scripts concept I'm explaining you now, guys. So let's quickly discuss the powerful optimization known as the map side joins. And bucketed tables help to make these joins faster in memory. Okay, the standard join in MapReduce involves a large shuffle sort step. Okay, what are those steps? The very first step is the mapper reads the data from both tables. Look at here. It is reading data from employee table and it is reading data from department table. So that is the job of mapper. Okay, so it outputs. Then what is the output of this? So it outputs a key value pair where a key is the join key. See, join key we have mentioned as 2 here. So key is the join key, or you can consider it as a department key, guys. See, this is the department key we have mentioned here, right? See, here also we have taken department key too. So department key as a what key value we have taken here, and the value is the row data plus the table source. So here we have taken that. Understanding my point, guys? You're all understanding? And see, after that, what we are performing? We are performing shuffle or sort operations. The shuffle or sort phase sends all values with the same join key to the same reducer. And after that, what is the job of reducers, guys? The reducer then perform the actual join logic. This is a massive costly network operation. Then you can ask me a question, sir, how bucketing optimizes join? Guys, if both employee and department tables are bucketed by the department ID or join key, and both of them are having the same number of buckets, and these are sorted within the what buckets by the join key. And then, so map side join can be performed. So this is, everything is done. Next, what we are going to do, map side join can be performed here. The MapReduce framework can guarantee that the ith bucket file from the employee table will only ever need to be joined with the ith bucket file from the department table. The meaning of this is, so it can happen, the join can happen entirely in the mapper. So without the need for costly network shuffle. Because the files are small and pre-sorted, the join process is faster in the memory. Try to understand this. So this map side joins is an incredibly efficient way to handle large table joins and is the key performance benefits of properly bucketed tables in Hive concept. So hope this this concept is crystal clear to everyone. Shall I get CC and chat box once it is crystal clear? Now we will explain you the storage format. Is this crystal clear? Okay. So now I'm explaining you the storage format. Look at here. This is the storage format. Guys, we have seen HBase in columnar, and for Hive, the move towards efficient storage also involves a columnar approach. So here also we are using columnar approach. Try to understand this. Historically, Hive used text files or sequence files, so which are row oriented. So this means that even if you only needed one column in your query, the input output system read the entire row of data. So to solve this, so formats like what is that? ORC. ORC means what, guys? Optimized row columnar file were developed. Okay, this is the evaluation of the RC file format. Okay, RC file format. Okay, this is hybrid approach, guys, designed for optimal high performance. So now you can ask me a question, how this ORC or RC files work. Okay, so this is called as, let me write here, this is called as hybrid row columnar concept. Hybrid row columnar concept. Guys, let me explain you step by step. The very first step is, so we are going to perform row grouping. Look at here. So we have mentioned row grouping. So see, it is showing in the diagram. The data is first divided into row groups. Understanding my point, guys? The data is first divided into row groups. Okay? Or we can call it as strips in ORC terminology. So row group 1 has row number 1. Okay, row number 1, row number 2, row number 3. So row group has what, guys? Row group 2 has 4th column and also 5th column. Correct, no? See, look at here. Row 1 is containing 11, 12, 13, 14. See, in column we have mentioned the same value. Okay. And row 2 group is containing what? 4th and 5th column. What is 4th column and 5th column? 4th is 41 and 5th is 42, 52. Correct, no? And next 43, 53, 44, 54. So I think everyone are understanding. So for row group 1, all the values of the column C1, all the values of the column C1, that is nothing but 12, 22 and 32 are stored together. Correct, no? Look at here. 12, 22, 32 is stored together here. And all values of column 2. What is the column 2 value? Sorry, this is column 1 value is 11, 21, 31. Sorry, guys. 11, 21, 31. It is stored here. And all column value of C2 is also stored here. 12, 22, 32 stored together. So on and so forth, right? Next column 3 value, column 4 value. Then you can ask me a question, sir, what is the benefit of it? Guys, fast column access is one of the benefit of using this. Or we can call it as the columnar benefit we are going to get from this. So when a query only needs column 2 value, Hive can read only the physical blocks corresponding to the C2 column. Completely, it is going to skip C1. Okay, it is completely going to skip C3. It is completely going to skip C4. So it is going to read only C2 value. That is one benefit of using this format actually. And second one is, the second benefit of using this is better compression. So because all the values from the same column are stored together, so they are often of the same data type and have similar values. So this similarity allows for much higher and more effective compression than in row-oriented format. I think everyone will agree with my point. So the first advantage is fast column access, and the second advantage is better compression. And we have third advantage also. The third advantage is read efficiency. Okay, compression is done and fast access also done. The third one is read efficiency. So Hive can quickly determine which row groups to read based on index information stored within the file itself. Guys, in big data system, so choosing an efficient storage format like ORC is a fundamental decision that can dramatically affect the query performance and also storage cost. Understanding my point, guys? And see, next slide, I'm giving you broader use of Hive metadata H catalog services. You can look at here. My dear friends, so we have learned Hive uses a meta store for structured data in a table with the data on HDFS. This metadata meta store holds the schema for the big data. The problem is that other component of the Hadoop ecosystem like MapReduce programs and Pig scripts can independently access HDFS data. So however, they would have to manually refine the schema and location of the data. So which is inefficient and also error prone, right? Okay, so this is where the H catalog comes in. Okay, so H catalog is the Hive Metastore exposed as the REST service for other Hadoop ecosystem tech to use. It acts as a unified catalog for all your data. Okay, so now you try to understand what is H catalog in action. Guys, H catalog allows other tools to see and use the tables defined in Hive. So Pick can also see now. Okay, and MapReduce can also see now. So this H catalog allows other tools to see and use the tables defined in Hive. Complete with their schema and also location. See, we have a what Pig integration here, correct? No, you just observe here. So we have a Pig integration. A Pig script can use this H catalog loader. Look at here, everyone. HCat loader we have mentioned, or HCat storer we have mentioned here. Correct? No. So the Pig script can use this HCat loader instead of manually defining the file path and schema with Pig storage. Okay, without H catalog. See, you can last class I have written the definition, right? See, look at here. We have mentioned here. So what we have mentioned here. So A is equal to load HDFS location we have mentioned using Pig storage as some data type we are going to mention here. Correct? No. So this is without using H catalog. Without using H catalog. Correct? Now we are not using here. With using catalog, look at here. With using catalog, so we have minimized the line. So we have written A is equal to load sales.csv using HCat loader. So this is much simpler and ensures the Pig script is using the correct consistent schema from the Hive Metastore. So this is about Pig integration, guys. This is about Pig integration. Then what about MapReduce integration? So we have one more, right? MapReduce integration. Guys, Hadoop MapReduce Java code can use this HCat loader and HCat store both. So this allows a MapReduce program to read data from a Hive table and save result back to the Hive table. So hope everyone understood with an example. So if you have any doubt on this, you can ask me now. Is this clear to everyone? So am I making you sense to everyone, guys? If I'm making you sense, then you type MS and chat box. Am I making sense to each and everyone? Yes or no? I'm not getting any response. Okay. Now look at here, guys. The very important thing what you have to understand here is, in essence, H catalog is used to coordinate a task working on the same data across MapReduce and also Pig. So it is the single source of truth for the schema of all data in HDFS. So it is an incredibly important service for enterprise scale data lakes. So where multiple tools needs to interact with the same data readably. Okay, same data reliably. And also this diagram you can observe here. So this diagram is clearly shows MapReduce and Pig communicating with the Metastore client. Look at here, Metastore client to access the schema information stored in the Metastore database. Correct? No? So this brings us to the end of our depth session on the 3 heavyweights of Hadoop ecosystem. So we have explained 3 tools, guys. In 8th session, we have explained 3 tools. So I think till here everything is clear to all. Is this clear to everyone? Shall I get quick responses in chat box? So everyone understood in detail what exactly it is? Okay, so shall we take 5 minutes break, guys? Now the time is 6:45. Shall we take 5 minutes break? So I will start the session at 6:50. So with a fresh concept. So is it okay for you all? 5 minutes break is okay for you all? What about others? Tanya only replied. What about others? Is it okay for everyone? Okay, then we will take 5 minutes break, guys. After 5 minutes break, I will start with new tools. Okay, guys, you all ready? So I'm back to the session, guys. You all ready? Shall I proceed? Okay. So all of them look at here. Guys, this slide simply reiterates the 4 key concepts or key tools. So we are focusing on for today's session. So one is a Scoop, second one is Flume, third one is Zookeeper, and fourth one is Oozie. Okay, so I want to use this moment to stress the significance of these 4. So they are often referred to as the utility user of the Hadoop ecosystem. Okay, then what is the first one? Guys, look at here. This Scoop. So Scoop gives structured data a bridge to the Hadoop world. And the significance of the second one, Flume, is Flume provides the what? Plumbing for streaming data. And Zookeeper is obvious. It is a conductor ensuring all the parts of the orchestra play in harmony. And last one is Oozie. So Oozie is the script writer and director for your entire big data movie. Okay, that is your pipeline. So usually this is called as a pipeline. Understanding my point, guys? So if you are aiming to be big data developer or architect, you must know how to use these tools effectively. Okay, they represent the practical day-to-day operations of the big data environment. So hope this is clear to everyone. You're all ready to become a big data developer or big data architect, guys. So how many of them want to become big data architect and big data developer? Quickly, can you raise your hands? Otherwise, put a message in chat box. So then you have to concentrate on this concept. That is very, very important. Okay. So now, yes, sir. So only one. Okay, Tanya. Okay, I got 2 responses. So now, guys, we are jumping into the very first one. So that is your Scoop. So look at here, guys. These are all very beautiful tools, guys, and it is very easy to understand. Guys, this is where it all begins for Scoop. See, look at the tagline mentioned here. SQL to Hadoop, Hadoop to SQL. So this is one of the perfect tagline, guys. SQL to Hadoop and Hadoop to SQL. Guys, Scoop is a mashup of SQL and Hadoop. And it perfectly describes its function. Then you can ask me a question, right? Sir, what exactly Scoop? Can anyone answer what exactly Scoop? Can anyone answer what exactly Scoop? Yes. Anybody know about this? I'm not getting any responses. What is Scoop, guys? So data transfer between, oh, that already I've told you, right, Arup? Jyoti, already I've told you the definition. Okay, transferring file. So usually, generally tell me, guys, what is Scoop? What is Scoop? Generally, what is Scoop? See, I'm relating with the real terms. So why it is named as Scoop? So one scoop of, yes, exactly. Correct, no, Jyoti? So you'll pick a scoop and then, okay, you'll put it inside a what, something. So guys, actually, yes, sir. So it is very similar to the what definition what I have given. So it is a tool in the Hadoop ecosystem that is explicitly designed to transfer data between HDFS and RDBMS. And this is very, very important point, guys. Okay, Hadoop by design was not created to natively talk to relational databases. Okay, your customer data, order history, and product details often resides in traditional databases like MySQL, Oracle RDB, SQLite, Teradata. Correct, no? Netezza and Postgres. Correct, no? See, we need that data in a Hadoop to run our complex big data analytics. So Scoop solves this integration problem. Understanding my point, guys? Is it easy to understand? Once again, guys. Correct, no? So, guys, Scoop efficiently transfers bulk data between Hadoop and these external data sources. So we are talking about massive bulk transfer, not a single record. We are not taking single scoop. So we are taking massive amount of data, bulk transfer. Okay, it supports two operations, guys. What are the two operations it is supporting? So one, it is supporting for import operation. Another one is supporting for export operation. Let us talk about the very first one, import operation. Guys, import operations means, see, look at here. I have mentioned import operation. So this is where you import data from the relational database, such as your MySQL, Oracle, into HDFS. Understanding my point, guys? See, for example, so you want to move a billions of row of customer order table from a MySQL server to HDFS means, then you can use this option import. And next we have export. It is vice versa. That's it. It is a reverse of import actually. Okay. So you export the data from the HDFS back to the relational database. Say you run a massive MapReduce job on HDFS and the final summarized result needs to be stored back to your relational database means, then you can use this export condition. And this visual representation, what it is showing, guys, it is showing the workflow very nicely. Look at here, you will understand very easy. See, here we have a Scoop client. Okay, so which can be CLI or browser. Okay, this is connected to the what? Scoop server. So this is connected to the Scoop server. Okay, so this communicate with the HDFS. See, look at here. So we have a Scoop server here. So that is communicating with the HDFS, Hadoop. Correct? No? You're all getting this point. So see, after this, Hadoop then uses mapper task, reducer task to read and write data from the external sources like enterprise data warehouse and relational databases. And this acts as a middleware to the entire system. So the core takeaway is Scoop is the bidirectional data pipe for structured data between your relational world and your big data world. So now we are getting the clarity, right? What exactly the definition of Scoop? Okay, now we are going to explore. So why Scoop? Why we need it? Correct, no? So let's be honest, guys. So this is the burning question. So if we can write Java code, why can't we just write a script to move the data? Correct, no? You can ask me this question, right? You're all getting my point. So Aram say we can write a program to what? Transfer data from one place to another place, right? Yes or no, guys? But the answers lies in the problem it solves and the efficiency it brings. Okay, so think about a big data developer. The real important work. What is the real important work of big data developer, guys? The magical stuff to find all the golden information starts once the data is already in the Hadoop system, like HDFS, Hive, HBase. They don't want to write time waste. They don't want to waste time managing the what? Mundane and complex task of bulk data transfer before this scope. Correct now? So moving massive amounts of data was tedious, slow, error prone. So we needed a dedicated tool for this. The tool is called as Scoop. So Scoop was a solution that filled this critical data transfer gap between relational databases and also Hadoop system. Okay, so here we have a what genuine point we have mentioned here. Look at here. Scoop uses MapReduce mechanism for its operation. for its operation. Guys, remember MapReduce. It is designed for massive parallel processing, right? Fault tolerance, right? By leveraging MapReduce, Scoop ensures that the import and export work is done on a parallel mechanism. As well as not only with parallel mechanism, as well as fault tolerance. So this means the data transfer is fast and also the data transfer is reliable. So as a developer, this is the simplified beautifully. Look at here. Developer just need to mention the source, destination, and rest of the work will be done by Scoop. So you write a simple command and Scoop handles all the complex partitioning, parallel connections, error handling for you people. It abstracts away the complexity of bulk transfer. So in essence, Scoop exists to provide a fast, reliable, parallel, and easy to use bridge for bulk data transfer, allowing big data developers to focus on analysis rather than integration. Sorry. Correct? No. You're all understanding. So why we need Scoop? Yes. And now look at here. This is the Scoop architecture. So let me see. So till here everything is clear. So you all understood what is the purpose of using Scoop. So once you have understood, please put a message in chat box, guys, quickly, without wasting time. So now I am jumping into architecture part. It is very easy, guys. It is very easy to understand Scoop concept. So yes or no, guys, till here everything is clear. Yes. Okay, now look at here, guys. So this is the basic architecture flow of Scoop. This diagram is a great mental model for how data moves. At its heart, Scoop is about moving data between a source and a destination. So what is source here? Guys, source, this is typically your RDBMS, like your MySQL, Oracle. And see what type of data it is storing. It is storing only structured transactional data. Correct, no? And what is destination here? Destination is Hadoop. Hadoop file system, HDFS. So which could be what HDFS? It could be HBase or it could be Hive. So this is your unstructured or semi-structured data lake where analysis happen. Okay, and finally we have a what Scoop tool. Look at here. So finally we have a Scoop tool. So this sits in the middle and perform the operations for import and also export. Correct, no? See here we have two flows, right? So one is called as import flow and second one is called as export flow. Guys, import flow means what? RDBMS to HDFS. Data flow from RDBMS through the import component of the Scoop tool and lands in the HDFS. So this arrow, look at here, this arrow is typically drawn in orange in the graphic, representing what? Data flowing into the Hadoop world. So export, I don't want to explain it, guys. So it is completely reversed to the import function. So remember the underlying power of this, guys. Both the import and export operations are parallelized using MapReduce task, and it is ensuring high throughput. So this simple, clean architecture is the key to Scoop's efficiency and reliability. Now you tell me, guys, is it not worth? Correct, no? Is it worth or not? Can you all tell me? Is it worth to you or not? So if it is worth, please put a message in chat box, worth. Quickly. Okay. I'm not getting any responses. My dear students, now I'm moving forward and I'm explaining you two different types of Scoops. So Scoop 1 and Scoop 2. First, we have to understand the difference between Scoop 1 and Scoop 2. Scoop 1 and Scoop 2. Okay, let me explain this first. So later I will jump to Scoop 2 architecture. Okay. See, like any good technology, Scoop has evolved to handle new requirements and architectural needs. That we all know that. So let's look at the main differences between Scoop 1 and Scoop 2. So this is the great point for interviews and understanding the what architectural shift. So let me take the features here. Let me write the features here. So based on features, I'm going to tell you the difference between these two. Then what is the very first feature I'm taking here? The very first feature I'm taking architecture. Guys, with respect to architecture, Scoop 1 uses client-only architecture. So this will use client-only architecture. But Scoop 2 use client or server architecture, both. Okay, this is the first one. Scoop 1 required all the connection details on the client side here. But Scoop 2 introduces server, centralized management, and security. So this is the single biggest differences between Scoop 1 and Scoop 2 with respect to architecture. And next one, I'm taking user interface, UI. With respect to user interface, Scoop 1 is going to use CLI based one. CLI based one, that's it. But Scoop 2 will use both CLI plus web based. Both it is going to use. So Scoop 2 adds web UI. So making it much easier to manage jobs and monitor transfers without constantly using the command line. So this is the second difference. And then what is the third difference? Third difference with respect to Hadoop access. Hadoop access. Guys, with respect to Hadoop access, Scoop 1 client access to only Hive and HBase. Client access to only Hive and HBase. But in case of Scoop 2, server access to the Scoop and HBase. Understanding, guys? And next we have one more. This is very, very important one. Woozy integration. Guys, Woozy and Scoop tightly coupled here in case of Scoop 1. In case of Scoop 2, Woozy finds REST API. Means Scoop 2 exposes a REST API, making integrations with the workflow tools like Woozy much cleaner, more flexible, less tightly bound. So these are the few concepts I've taken, guys, to differentiate Scoop 1 and Scoop 2. So now I'm jumping into Scoop 2 architecture. Everyone look at here. So I am going through what Scoop 2 architecture. So let's focus on the enhanced architecture of your Scoop 2. So this slides clearly shows the client server separations we just discussed. And also we all know, right? So that is the significant feature. See, on the left, we have user interacting with the Scoop client via CLI or browser. Okay. Understanding? The core difference is the central purple box. Okay. This is a very, very important one. Central purple box is very, very important one here. That is called as Scoop server. Look at here. It is called as Scoop server. This server acts as a centralized control point and it contains several vital components. What are those vital components? The very first one is REST, UI, job manager, connector manager, connectors, metadata. What is this REST and UI? So these are the interfaces for the user and other systems. So suppose Woozy has to communicate means, then it can use this REST and UI. Understanding my point, guys? So next to that, we have a job manager. So this is responsible for managing the life cycle of the data transfer job. And next to that, we have a what connector manager. And along with that, we have a connectors here. See this connector manager and connectors. So these two are crucial security and management layers. And the server centrally manages the connection logic and details for various sources and destinations here. And finally, we have metadata component. So this is giving you what information about the connections and the job is stored here. So where job is stored? So job is stored inside the metadata repository. So this server is backed. This entire server is backed by a metadata repository, which stores all the job definitions, connection details, and other persistent informations. Guys, when a transfer job runs, a Scoop server communicates with the Hadoop ecosystem. Look at here. So it is communicating with the Hadoop ecosystem. So the transfer itself is still parallelized using map task. Okay. So, and optionally, we can take reducer also, guys. Okay. Reduce task also we can include here. So I have included only map task here. So which moves the data to and from the various sources like data warehouse, relational databases, and document-based systems. And sometime, yes. So sometime, so it is going to what? Send a data to back to the what? HDFS, HBase, and Hive layer in Hadoop. And a very, very important thing, you have to make a note of this, guys. The Scoop 2 client server model offers better security, better resource management, and cleaner separations of concerns, making it more robust for enterprise use. Now, how many of them understood this architecture, guys? So everyone understood architecture? Can I get quick confirmation? Everyone understood architecture? So once you all understood architecture means now I'm going to explore the powerful features that make Scoop so essential. So are you all ready, guys? Yes or no? Shall I get the confirmation and chat box? Guys, my voice is audible to everyone, right? I'm not getting any responses. Okay. Now look at here, guys. Guys, the Scoop is more than just a simpler transfer tool. It has a rich set of features that make bulk data movement robust and flexible. Okay. The very first point I've taken here is full load. Guys, you can load an entire table by a single command. Even better, you can load all the tables from the entire database using just one command. So this is the great for initial loading and building a data warehouse from the scratch. Okay. And second point I've taken here is incremental load. This is the massive time saver, guys. Scoop allows you to load only a part of the table that have been updated since the last import. You don't want to re-ingest a terabyte table just because 100 new rows were added. Understanding my point, guys? And it supports two types of incremental imports. What are those two types of incremental imports? One is append and second one is last modified. Append means for a new rows added to the table. So last modified means for rows that have been updated. Okay. And next we have one more feature that is called as parallel import or export. Guys, already I've mentioned this, right? So this is the key concept, right? So Scoop uses Yarn framework, which manages resources for the Hadoop to parallelize the what data movement. This parallel execution is why Scoop is so fast and also provide fault tolerance. And what is the fourth feature? So import results of a SQL query. So you don't always need to need the what whole table. Scoop can import only the result returned from the SQL query into HDFS. So this powerful for pre-filtered and also subsetting data. And along with that, we have one more, that is compression. So big data means what, guys? Big data means it needs big storage needs. So Scoop can compress data using algorithms like, see, it is using algorithms like deflate, or we can call it as gzip. Okay, by using this, so it will compress the data. And it is specifying a what custom compressing codec. Okay. And yes, it can also load compressed table directly into Apache Hive. So this saves space and often speeds up the processes. Correct, no? Speeds up the processing, right? And what is the next one? Connectors for all major RDBMS databases. Guys, Scoop is almost universal compatible. So providing connectors for multiple RDBMS databases, effectively covering almost the entire circumference of databases technologies. And finally, load data directly into Hive and HBase. So Scoop can load data directly into Apache Hive for analysis and also dump data in the NoSQL databases. That is nothing but your HBase. So this bypasses an intermediate step to HDFS and making the pipeline cleaner. Guys, these features demonstrate Scoop's maturity as a data transfer solution. So now what I'm doing, now I'm breaking down step-by-step process for an import operation. Look at here, this is the import operations diagram. You all observe here. This is another very, very important one. Okay, so guys, let's walk through the 5-stage Scoop import overview. So this gives us the process level view of how the parallel transfer works. The very first one, look at here, I mentioned the very first step here, run import. So this is the client action. Okay, the process starts with the client running the Scoop import. I'm writing here Scoop import command. Okay, so this command tells the Scoop system what to import. Understanding my point, guys? So whether it is table name or connection string or etc. So this is the very first step, run import. And what is the second step? Pull metadata. This is the second step, pull metadata. So here Scoop in actions, guys. Here client in action, here Scoop in action. Okay, guys, this Scoop connects to the RDBMS. So which could be MySQL, SQL Server, Oracle, or DB2. Okay, and pulls the metadata. Along with this, it will pulls the metadata. Okay, the metadata includes the table schema, column types, primary key information. So this is essential for converting the RDBMS data into a format suitable for HDFS. So this is the second step. And what is the third step? Launch MapReduce job. Look at here. So this is the third step. Launch MapReduce job. So again, Scoop in action here. So based on the metadata, Scoop launches a MapReduce job. So Scoop automatically partitions the import operations based on the partition column. Sometime it will take primary key as a partition column, guys. And it will create multiple mapper task. Okay. And what is the fourth step? So pull data from databases. See, where is the fourth step? Here we have a fourth step. So pull data from database. So this is the job of mapper. Okay, this is MapReduce action. Okay, this is MapReduce action. Guys, this is where the parallel magic happens. So each individual map scoop, look at here. Each individual map scoop connects to the RDBMS and pulls the specific distinct chunks of data because they are all running in parallel. This bulk transfer is extremely fast, guys. So this is we are going to do in fourth step. And what is the final step? The final step is write to the data sink. Okay, this is again MapReduce action. Finally, guys, each map task writes its chunks of the data into the data sink. Look at here, we have mentioned data sink here. Okay, the data sink is the destinations in Hadoop. So typically HDFS, here I mentioned HDFS, Hive, or HBase. The result is a set of files in a HDFS. So usually, guys, the result is going to show in this format, right? Part -m -00000. This you have seen, right? and then part -M00001. So this is the output files actually in HDFS, result file actually. So each corresponding to the output of parallel map task. Guys, this process highlights the elegance of Scoop. It uses MapReduce not for computations, but for parallel input-output. Correct? No. And making the data transfer process highly efficient and also scalable. Okay, so how many of them understood this concept clearly? Now I will show you actual command structure for importing data. This architecture is crystal clear, means I will jump to what command structure. So till here everything is clear. Guys, so one line you're writing means you will become a big data developer. You can inject data from structured RDBMS. So is this clear? Yes or no? Shall we take one command? I am not getting any responses. Okay, guys, no problem. Guys, look at here. Let's get practical, guys. So the ultimate goal of learning about Scoop is to be able to use the Scoop import command. Okay. The import command is used to import individual tables from an RDBMS to HDFS. Okay. It is crucial to understand how data is represented. Okay. Each row in the RDBMS table is created as a record in HDFS. Try to understand the second point. Each row in a table is created as a records in the HDFS. Okay, all these records are stored as either text data in text files or binary files. So I think this import command is crystal clear to everyone. Now let us look at the generic syntax and essential argument for importing a table. So the very first line is missed here. Let me write here. Here we have the very first command as -connect. This line is missed here. So I'm writing. Guys, the very first line. See, -connect we have mentioned here. So this is going to give you the JDBC URL. Okay. So this takes the JDBC URL and connects to the database. Okay. So this is how Scoop finds your source in RDBMS. Understanding first one. And next to that, we have table. -table. Look at here. This specifies the source table name to be imported. And next to that, we have username and password. So these are the credentials required to connect to the database. And finally, we have target directory. Look at here, -target directory. So this is the directory in HDFS where the data will be imported. Okay, so is this clear? So this command is crystal clear to everyone. All the points are crystal clear to everyone. Shall I get quick confirmation? I will give you one analogy if you want this. Otherwise, I will move forward. You want me to explain with one analogy? Yes or no? I am not getting any responses, guys. I want you people to interact with me. I am not getting your interactions. Yes. So now let me take one small analogy. Okay. So think of the import command as filing out a shipping label. Okay. You specify the source address, right? What is the source address here? Yeah, I will show you command, Pradeep. Can you wait for a while? Okay. So what is the source address? Source address is nothing but your JDBC URL, right? Correct, no? And the destination address is target directory. And the keys to open the source gate, that is your username and password. Guys, the actual command executions, I will show you later. Okay, so in the examples. But first, we have to understand the explanation. So for that reason, I've taken time to explain this. Okay, now I'm moving forward. See, this is exporting data using Scoop. Okay, see, after you have done your analysis in Hadoop, you often need to send results back for reporting or application consumptions. So this is where exporting data using Scoop comes in. Guys, the scoop export command is used to export a set of files from HDFS back to the RDBMS. The logic is simply reversed. Okay, the files given as input to scoop contains records that will be created as a rows in the target table. See here, it is showing the architectural diagram. Try to understand this diagram. The user requests a scoop export. So scoop first gathers the metadata. Okay, scoop first gathers the metadata. Correct, no? Yes or no? From the what? Target RDBMS table, like orders. Okay, like orders. Then it submit a map only job. Then it will submit a what? Map only job. So these map task reads the files from the Hadoop cluster. See, look at here. It is reading everything from the Hadoop cluster and in parallel writes the records back to the rows in the RDBMS. So this is looks at the what? Generic syntax, general format, right? And this is the syntax, guys. So here also connect is missed. So here also connect is missed. Guys, first connect. So again, JDBC URL connect to database. This is the target in this case. And next we have table. So table specifies the source table name to be exported. Correct, no? Wait, this should say target table name. Okay, so it is the table in the RDBMS where the data is being written to. Try to understand this. And next we have username and password. So these two are the credentials for the target RDBMS. And finally, we have target directory. So this is the HDFS directory from where the data will be read and exported. Guys, the structure is almost identical to the import command, which makes it easy to remember. Correct? No, you are just flipping the directions of the flow. That's it. So while scoop is incredibly useful, it is not without its drawback. Let's discuss the limitations of this scoop. See, here I have mentioned few limitations. The very first limitation says it cannot be passed or resumed. Guys, a scoop transfer is considered an atomic step. You cannot stop it midway and start from where you left off. Okay, so if it fails, you need to clear things up and start again. So this means that for very long running critical jobs, you must be prepared for special handling in case of partial import or export failures. You have to manage the cleanup yourself. That is the second disadvantage. And next one is export performance deficiency. Export performance deficiency. Guys, scoop export performance also depends on the hardware configuration. It will be always depends on the memory, hard disk, whatever you have used of the RDBMS server. Okay, you are dumping massive amounts of data into relational databases. So which has its own input output, transaction limits. So scoop can only write as fast as the RDBMS can handle the incoming load. Correct, no? And third one is inefficiency about JDBC connections for some use cases. Guys, scoop uses a standard JDBC connections to connect with RDBMS. See, for some very high volume or specific database platform, this generic JDBC approaches can be inefficient. And also it is going to offer less performance compared to the native connector. Okay. However, for a few databases, Scoop does provide a bulk connectors which has faster performance. The main point to remember is the lack of resume feature. So this is the significant operational considerations for productions data pipelines. Okay, so here I have a Scoop import and export. You all look at here. This slide is visually summarizes the core functions of Scoop. So think of it as a ultimate connector for structured and also warehouse data. Okay, Scoop at its center. See, Scoop at its center, it is capable of facilitating data movement to and from RDBMS, data warehouse, and also NoSQL. Okay, and destinations within the Hadoop ecosystem. So the destinations include HDFS, Hive, and HBase. The transfer are always powered by this mapper task. So which is ensuring parallelism and fault tolerance we discussed. Guys, in simpler term, if you have structured data in any external system, need it to be in Hadoop, or if you need to take processed data from Hadoop and put it back to the what structured system. So scoop your go-to tool, guys. Understanding, guys? So till here everything is clear, miss. Now I will take the example to explain on this. So till here everything is clear. I will show you, Pradeep. Okay. So now I'm taking the example. Once I'm taking the example, then you will understand. Okay. So here I'm taking the examples, guys. You just look at the example here. So look at the example here, guys. So here we have a what dollar prompt. So in front of the dollar prompt, what we have mentioned? We have mentioned scoop keyword, then import keyword, and next to that, this is hyphen, guys. This is not two hyphen we have to use here. Hyphen connect, and then we have taken what we have taken here: JDBC MySQL and complete URL we have taken here. And next to that, we have table name we have mentioned here. Columns names we have mentioned here. Correct, no? Column names we have mentioned here. That's all very simple, no? So the very first one is scoop import. So this is the first part I was explained you. So this tells the scoop to perform an import operation. And next to that, we have a connect. So what is connect? What is the job of connector? The JDBC URL specify the MySQL server and database corporation. And next to that, we have a table. So table name we have taken as employee here. So this is what? This is the table is being what? Imported. And next to that, we have columns here. So this column, this is very, very important, right? Okay, it specifies a subset of columns to import. You don't have to import the entire table. So even you can import what sub part of it. Okay, and next to that, see, look at here. Another very, very important thing is split by department ID. Guys, this is the column scoop users to parallelize the import. Okay, so scoop will create a separate map task for different ranges for department ID values, and it is ensuring fast parallel transfer. And what is the output it is showing here? See, once you have done with this, you have tried Hadoop, FS, LS, employees, that's it. See, immediately it is going to create two outputs here. Part M 00000 and part M 0001. This already I have explained you, right? See, two files are generated now. These are the two files written by the mapper in parallel. So this is about scoop import. And next we have scoop export. It is very much similar to your scoop import, guys. So again, we have scoop export here. And next to that, we have connect. So connect means JDBC connection we have mentioned here. So this is a JDBC connection and target table in the RDBMS. And next to that, we have a table. So what is this table bar? So why we are going to use this table bar? So it is going to mention the target table name, right? What is the target table name we have mentioned here? So we have mentioned it as a bar. And next to that, so we have export directory. See, /result/ bar data we have mentioned here. The HDFS directory containing the files to be exported. So this is your HDFS. So finally, we also see the other commands like merge data, okay, eval, to run the what? SQL, etc. Okay, the scoop eval command is particularly useful for quickly executing a query against the RDBMS from the command line. So which we will see in the next set of examples, guys. So now I'm not showing you anything. So I have explained you only import and export. So both I have explained you. Okay. So I think till here everything is clear, right? So this is the commands I have given. So you people, you just go through this. I'm not going to explain you the entire command. And I have shared you, and one more thing, guys, I will tell you later. At the end, I'm going to tell you one more thing. Okay, this command I have mentioned here, you just go through this later. So that's all about the scoop concept, guys. So if you have any question on this, you can ask me. So you just reorient yourself, guys. What is scoop? What we have learned in scoop concept? Is it interesting? So how many of them are feeling this is interesting? So we have completed our deep dive into scoop concept, right? So scoop is for what, guys? Scoop is for what? So is there an example for importing data from multiple tables in a single import command? Yuvraj, I'm going to share you worksheet. So in that worksheet, you have all the commands that you can practice later. Okay, if I target only on scoop means, then it will take another 2 hours to complete. Okay, so I'm at the end, I'm going to show you where you have to find worksheets. So in that worksheet, we have mentioned all the commands on scoop. Okay, that is there in your. Otherwise, I will share, guys. No need to worry. Okay, so is this clear? So scoop is for what, guys? Scoop is for structured, bulk, and batch data. Many of them will agree with my point. Yes or no? Everyone will agree with my point. Yes. Now I'm jumping into Flume. Okay. Now I'm jumping into Flume. See, look at here. The second one is Flume here. So let me check how many slides are there for Flume. Yeah, I have only few slides, guys. At least let me complete Flume concept now. Okay, quickly I will go through Flume concept. Guys, a Flume is for completely different scenario. So this is for semi-structured, streaming, and real-time data injections. If Scoop is the reliable cargo ship moving containers, the meaning of that is it is used for only table movement, right? But Flume is the pipeline pumping a continuous flow of fluid. Okay, so your log files, events, everything I can move here. Okay, so see, now I'm trying to introduce Apache Flume to understand why Flume exists. And let's consider a scenario, guys. Before I'm going to explain you this, so let's consider a scenario. So imagine an e-retailer generates customer browse, buy logs on its website, every click. So every product view, every purchase, that's all means all about continuous stream of semi-structured data, right? So this data needs to be streamed into a Hadoop environment for analysis of customer behavior by the data analytics team. This is not a once-a-day bulk dump, right? So it is happening right now. Okay, so this is exactly what Flume is built for. Guys, Flume moves. Okay, logs from source application servers to HDFS files. So it's the data pipe from your source system to your Hadoop storage. And second one, so it performs reliable buffering and message delivering for occasional data spikes. So if your website suddenly gets a massive traffic surge, so Flume can buffer the events so they are not lost and ensuring reliable delivery. And third point is mentioned scales with the workload. You can easily add more Flume capacity, more agents as your data streams grows. And fourth point is can easily managed and customized. Guys, it is a highly configurable for different sources and syncs. And also it is supporting for parallel transfer. And it is allow contextual routing. Okay, so you can inspect the data and decides where it should be sent. Maybe all error logs go to one HDFS directory. All purchase logs goes to another directory. So like that, you can use it, guys. So Flume Superpower is reliable, scalable, real-time streaming of semi-structured data in Hadoop. Okay, but wait, guys, why not just use a simple HDFS put command in a script? Correct? No. So even put command is doing the same thing. Why can't we use put command? That is the question you have to answer. So now look at here. I'm answering the same thing. A great question to ask here is, why can't we simply do an HDFS put? This is another interview question for you people. Guys, there are two major reasons why a simple HDFS command line upload is poor solutions for streaming data. The very first one I have mentioned here. It is a one-time command. We need to reliably stream data. Guys, a log file is continuously being what returned to, correct? No? But a put command is what, guys? Put command is static. So one-time file copy, that's it. You need a process that continuously monitors the log file, reads a new entries and sends them back. So for that reason, you are going to use Flume. And the second reason here is given, failure is catastrophic. Okay, if a process partially copies data, or if a failure happens in the middle, the HDFS file is not closed and its size might be 0. This means data loss and corrupted files. Guys, streaming injection is fundamentally different from batch transfer. What it requires, guys, it requires readability, reliability. Okay, reliability means what? It has to guarantee that data is not lost, right? And buffering is also very, very important. The buffering means a temporary place to hold data during network hiccups or processing spikes. And one more thing, continuous operations also very, very important. It must run for what? 24/7. Guys, once you need all these three, then the solution is Apache Flume. Okay, Flume provides robust, reliable, and fault tolerant streaming capability we need. Okay, it is overcoming the limitations of simple file copy command. It is overcoming the what? Disadvantage of this put. Correct, no? So now you try to understand the architecture of this. This is giving you the what architecture. Guys, the fundamental unit of Flume deployment is the agent. Look at here. So agent is very, very important here. An agent is a single JVM process. It is a JVM process. Okay, that moves data from an input to the output. And it also possible for it to send data to other agents. Okay, and look at here. Every Flume agent consists of 3 main components. Every Flume agent consists of 3 major components. What are those 3 major components? The very first one is source, and second one is here source, second one is channel, and third one is sink. Okay, let us try to understand these 3 things first. What is source? Guys, this component receives data from the data generator or from another Flume agent. Okay, so it is pluggable for different types of input. See, for example, you have an Avro source is used to what? Receive data from another Avro source equipped agent. So it is the intake data point, guys. The source is the intake data points. Okay, that is what I'm trying to explaining to you now. And next we have a channel. So what is this channel is? So this is the transactional transistent data store. So think of it as a what? Secured buffer. Secure buffer. So it acts as a what? Bridge between one or more sources and also sinks. Guys, channels are crucial for reliability, and they can be what? Configured for different types such as JDBC, memory, file system channel. If the sink is temporarily unavailable, the channel holds the data. Okay, and finally we have sink, guys. So sink is the component that consumes from the channel and either what? Stores in the central store. So it will stores inside HDFS, stores inside Hive, HBase things, wherever you want. Along with that, not only that, guys, it sends it to the what? Another agent also. And it is the data output point, guys. So this is data input point and this is the data output point. Okay. So Flumes work on a unit of data called event. Try to understand this. So it is working on the event. This is the basic unit of the data transfer. So event is a basic unit of data transfer and typically it is consisting of two things. What are the two things? It is consisting of header. Okay. And also along with that, it is consisting of byte payload. Header and byte payload. Header means for metadata. Header for metadata and byte payload for actual data. Okay. So this is a very important point for reliability, guys. So Flume guarantees reliable messaging through transactions. For each event, two transactions happen. So one at the sender and one at the receiver. The sender only commits its transaction. Okay. After the receiver commits its transaction, after the what? Receiver commits the transaction. So this prevents data loss. Okay. So this source channel sync model. See here you are seeing, right? Source channel sync model forms the backbone of Flume reliable, flexible, and scalable streaming injection. Okay. So now we have few other components, guys. You just look at here. Other than that, we have few other components. So while the source channel sync are the core of Flume agent, so there are few other components that provides the flexibility needed for complex and real world topologies. First one is called as interceptor. Okay, interceptors. So these components are placed between source and the channel. So here we are going to place this source and the channel. They are used to inspect or alter events before they are returned to the channel. See, for example, an interceptor could add a timestamp to every event or remove sensitive data. That is the job of interceptor. And what is the next command? Next command we have channel selector. This is the next command, channel selector. Guys, these are used to select which channel to send the event on when a source is connected to multiple channels. Okay, that is one thing. And second one is replicating default channel sector. So this will replicate the event to all the connected channels. See, for data backup, multiple processing stream, for everything. Okay, and next to that we have one more that is called as multiplexing selector. You know what is multiplexing, right? So this will select the channels based on some logic, often by what inspecting header of the event. So this is used for contextual routing. Understanding my point, guys? So next to that we have one more that is called as sync processors. Guys, these are used to select a sync in a group when multiple syncs are connected to a single channel. So they are used for failover. So guys, if one sync fails, so switch to another sync. That is the job of the sync processor. And along with that, so it will load balance across multiple syncs in a channel. The meaning of this is it will distributing the write load. That is what exactly it is doing. And finally, guys, see, these are the concepts you have to understand. And finally, by using these components, Flume data flows can have various technologies. What are those various technology? So we have multi-hop, fan in, and fan out. What is this multi-hop? You can ask me, right? A data stream is passed from agent 1 to agent 2, agent 2 to agent 3. From one agent to another agent, it is passing. And what is this fan in? So fan in means many agents sends data to single data collector agent. So when it is useful, guys, this is useful at the time of what? Aggregation, right? At the time of aggregation, this is useful. And what is the last one? Fan out. What is fan out, guys? One agent sends data to multiple destinations. Multiple destination syncs are multiple destination agents. Guys, and also you can observe here. The diagram showing what multiple agents flow into data collector. Okay, so which then flows to centralized stores. Look at here. From multiple, it is collecting, and also it is going back. So in our classic fan-in topology. So it is demonstrating common aggregation pattern. Okay, so now, so once we have done with everything, means look at the example. So this is the best example to understand the entire concept. So this stream, see, I have taken the example of stream live tweets into HDFS for big data analysis. Okay, what is the setup, guys? The setup is very simple. You create a Twitter API based Twitter API based app for data source. That is the first thing you have to do. This application is what will actually connects to Twitter Firehose. Twitter Firehose. Okay, you install an HDFS sync. So next to that, you have to install HDFS sync. So this is the destination component in your Flume agent. That's all we know. And you set up Flume. Okay, you set up Flume and configure it with the app as a source and HDFS as a sync. So this is what exactly we have to do. So then what is the diagram illustrating here? The diagram illustrates the agent. So what are the agents? See, first one, the Twitter service is the external data generator. And next to that, we have a Twitter source. The Twitter source is the Flume source component that consumes the stream from the Twitter API. And next to that, what do we have? So we have a memory channel. Correct? No. So this acts as the transient buffer. And next to that, we have a HDFS sync. The HDFS sync consumes events from the channel and writes them as a files into HDFS cluster. Guys, this is a beautiful example of a streaming pipeline. So Flume, with its reliable source channel sync configuration, guarantees that the flood of real-time tweets is captured without loss and stored efficiently in HDFS for immediate analysis. So is this clear to everyone? Till here, everything is clear. So you are all feeling it is very interesting, guys. Are you all feeling it is very interesting? So now I'm going to show you the configuration file for an agent actually looks like. Okay. So now look at the practical things. See, look at the practical things, guys. Everyone observe here. So simple test scenario I'm performing here. The steps for running Flume are straightforward, guys. So the very first line is install Flume. Okay. And create a config for an agent and run Flume. That's all. Very simple. The command to start the agent is, then what is the command to start the agent? The command to start the agent is sudo flume ng agent -c. See here, full dot I have taken -f flume dot config -n and then a1 dflume dot root dot logger is equal to info console. See here, the very important thing what you have to understand here is this part is very important. -f flume config. So this specifies the configuration file. And next we have -n a1, right? So this specifies the agent name as a1. So this is the agent name. So we are mentioning agent name as a1 here. Understanding my point? Once running, you create a logs at the source. Okay, you create a logs at the source. Okay, so for that, what you have to do, guys, you have to mention sudo sh-c echo command you are using here, echo hello Flume you are mentioning here, and then you are giving destination address. See, this command writes a line to a log file. If this file is being monitored by a Flume source, Flume will ingest the new line. And finally, guys, finally, you can view output at the logger sync. Okay, that is the final result. The key takeaway here is the agent configurations. So which is typically written in .config file. .config file actually. So let's look at the what config details on the next slide. See here I'm giving you what config details. Okay, so see here only I mentioned everything. So this is the configurations details. So first you tell the agent what component it has. What component it has, guys? So a1.sources is equal to R1. See, one source named R1. The meaning of this is one source named R1. And next a1.sinks is equal to K1. So one sink named K1. And a1.channels is equal to C1. So one channel named as C1. That's it. Okay, one name we have given for source, that is R1. This is for agent. Okay, sorry, this is for sinks, right? Second one is for K1 is for sinks, and third one is for channel. Okay, so next configure the source. See, this source is a spooled. See, look at here, everyone understand here. Spooled dir I have mentioned here. This source is a spooled dir type. This source type monitors a directory for a new completed files. So what we have mentioned here, guys, a1.source.r1.type is equal to spool directory. So a1.sources.r1.spool directory is equal to, I mentioned the path here. Understanding my point, guys? And the very, very important step is configuring these sinks. So configuring the sinks, what is the sink name we have taken here? Sink's name we have taken as K1 here. The sink type is a logger sink. See, look at here, I have mentioned here. Sink type is a logger sink. So this sink is for testing and simply logs the event details to the console and showing that event made it through the pipeline. Okay, so now look at here. So A1 sinks.K1 type is equal to logger we have mentioned here. Correct? No. So this is third step actually. Then what is the fourth step? So we have to configure the channel. So we have to configure the channel, right? The channel type we have taken as memory here. So this channel stores events in the agent RAM. Okay. So it will storing in the what RAM actually. Why we are storing it in a RAM? Because it is a fast but not durable if the agent crashes. Okay. So what we have to mention, see first line, a1.channels.c1.type is equal to memory we have mentioned here. So a1.channels.c1.capacity also we have mentioned here. See maximum events to hold. So this is we have taken here. And next to that, so we have taken a1.channels.c1.transaction capacity is equal to 100. See, this is maximum events per transaction. See, this is the memory capacity we have taken here, and also we have taken maximum transactions, events per transaction. Events per transaction is equal to 100 here. Okay. And finally, see, everything is done. Finally, so you connect everything together. So what we have to do that? What we have to do for that? So a1.sources.r1.channels is equal to C1 we have mentioned. So here source is equal to R1. Correct? Now source R1 feeds channel C1. That's it. Source A1 feeds channel C1. And next to that, see a1.sinks.k1.channel. What it is doing is equal to C1 means. So here sinks K1 reads from the channel C1. Reads from the channel C1. So this configuration file is essentially defines the entire flow and behavior of your Flume agent. Okay. And one thing is very, very important. So here I've given a comparison between these two, Scoop and Flume. I think you people will go through this. So I don't want to explain each and everything in detail, but I'm going to tell you one core difference is the nature of data and also the operation. So Scoop always take batch transfer of highly structured data. So Flume will take always continuous transfer or semi-structured data. So you can take logs file, events file, whatever you want. But what I'm going to tell you is, so both are essential. Okay, but they solve completely different parts of the data injection problem. That you should understand. And here we have given difference between Kafka and also Flumes, guys. So this I'm giving you as a homework problem. So you just go through the, I'm not explaining Kafka now. So without explaining Kafka, I'm explaining you the Flumes, then it will become difficult for you people. But the key difference I'm explaining here, Kafka is for general purpose distributed streaming platform that is used for messaging, pub sub, stream processing. But Flume is a specialized tool for reliable log events collection specifically into the Hadoop ecosystem. So however, you can work together. So Flume can have Kafka channel, so which stores events in a Kafka cluster that you can use together. That is, everything is left to you people. So that's all about the entire concept of Flumes, guys. So next class, I'm going to cover these two. So still I have not covered the 9th session concept. So I think the time is up, right? So time is already 8 o'clock. So I've taken 10 minutes extra. So we have left with Zookeeper and also Woozy. So I will try to cover this Zookeeper and Woozy in the next coming class. Otherwise, yes, guys, as usual, I have to take one extra class to complete the syllabus. So that's all about today's session. So next two tools I'm going to explain in the next coming class. So what is connect in Flume.config? So now you have understood, right, Pradeep? Pradeep, have you understood this? Okay. I don't know when you have asked this question. So maybe, yes, after this explanation, you have understood this. Okay, guys, that's all about the two tools. We have left with two more tools. That tools I'm going to cover in the next coming class. Maybe in 10th session, I'm going to cover all these things, guys. Okay, and before this, yes, I want to tell you one thing. So can anyone open your Taxila portal? Can anyone open your Taxila portal? Jyoti, can you help me? So I'll do one thing. So have you opened Taxila? So who is opened? I have enabled your mic, guys. So can anyone talk to me?
Yes, sir.
Jyoti, you have opened? Tanya. Okay, Tanya. Okay. So can you open one more option here? Do you have this option on your system? Labware? Do you have
Let me
Labware
check.
option? Yes.
Let me check, sir. Labware.
You just click on that semester. It is showing one list, right?
No, it's only showing semester 1 to semester 1, other everything.
No, where you are seeing. Have you gone to my courses?
Yes.
So in my courses, is it showing semester?
Yes.
In semester, can you click on that list box? See, I'm showing you on the screen. You're finding
Labware
this
option is not coming. Only the courses names are coming.
only courses names. Where you are seeing, I'm not getting. Can you share your screen, Tanya, if you don't mind?
Sure, sir. But it's showing I don't have permission to share.
Once again, I'll give you the permission. There is no presenter mode for you. Can you share the screenshot at least on the
Yes,
chat
sir.
box? Whatever you are getting. You click on that list box and share me the screenshot. Tanya, you're sharing?
Yes, sir. Sent on the chat.
Second. No, why you have clicked on big data system? Can you come back? Can you come back? I was showing you this, right? This
No, I'm
interface.
not on big data course. Mine
This
is,
page. I'm looking for this page. My courses. You click on my
yeah, I'm
courses.
on my courses. Mine is last with the screenshot before Yuvraj has shared.
Okay, okay. Is this not yours? Can you share yours? Okay, that is
Yeah.
the next one. Right? So it is showing only S1 25, other and
Yes.
everything. Nowhere you people are getting labware.
No.
मेरे मोबाइल को लेके जाओ.
No, it's not coming.
So in tabs also you're not getting.
No.
See here also that option is not visible to you, right?
No, sir.
Okay. Do you know my mail ID, Tanya?
Yes, sir.
Can you share this screenshot through my mail? And can you
Sure, sir.
request for labware
Sure, sir.
by putting a message? I will forward the same to administrator. The purpose is, the main purpose of using this is, I will show you guys, you just look at here. So once you are entering into this, I am showing you. See here, you have all the exponential learning concepts. So once you are clicking on this, so you will get programs, okay, commands, everything. So mapper program is present here. Hadoop streaming PDF also we have mentioned here. So here we have mentioned each and every steps. Okay, so even Python program is also there, and the Java program is also there. So if you people are comfortable with the Java program, you can go with Java program. Are comfortable with Python means, you can go through Python programming. So like that, so we have listed all exponential learning concepts here. So what you people have to do, you have to complete this. So after completion, you have to mention, so it is done. So this is compulsory for you people, you have to complete it. So hope you all understood what I'm trying to explaining you. Is this clear, Tanya?
Yes, sir.
So that is a must for everyone. Okay. So here it is not showing. I will ask administrator to enable that link. Okay. So any questions on today's session? Tanya, Arup, Pradeep, Tony.
No, sir. Crystal clear.
Okay. Then we can wind up today's session. Okay. So yes, I will try to take one extra class to complete the session 9 concept. So today, this is 10th session. So we have to complete 10th session concept, but still I am in 9th session concept. So I have to cover 9th session concept and also 10th session concept. That I will take one extra class to complete. So, okay, guys, is this okay for you all? Okay, I will inform you on this later. Okay, but before your 11th session, you are going to get your assignment, guys. That I have to see the date. So based on the date, I'm going to release the assignment for you people. Okay, you have any questions on assignment means you can ask me now. Do you have any questions on assignment? You all understand?